Welcome to our transport phenomenon presentation for our chosen topic of transdermal drug delivery, where we explored pain relieving patches from Salone Pass, presented by Delvis, Abhishek, Miskana, and Rade. To begin, what is transdermal drug delivery? Well, the Latin prefix trans means across or through, while the affix derm means skin. And so transdermal refers to any medicine or drug that enters the body through the skin, either through skin applications or patches that allow the body to slowly absorb the drugs. But how is the skin able to absorb the medicine? Well, the drug is able to enter the body by diffusing through many layers of the skin until it is finally able to reach the blood capillaries, where it can be transported to any part of the body through blood vessels. Diffusion is able to transport molecules across membranes by using the thermal motion of molecules as its driving force. Unless a molecule is at absolute zero, it's always vibrating and colliding with other molecules, especially in higher temperatures. So diffusion uses this thermal movement to allow molecules to spread across fluids. Now that we understand the basics of transdermal drug delivery, what are Salone Pass pain relieving patches? Well, Salone Pass pain patches take advantage of diffusion to safely transport active ingredients like menthol and methyl salicyate to relieve pain in the body. Menthol, commonly found in mint leaves, is known to provide temporary relief for arthritis pain, backache, muscles or joint pain, or even bruising. Meanwhile, methyl salicyate is an analgesic, which is a drug that helps with pain for arthritis, strains, sprains, and bruising as well. Salone Pass uses these active ingredients in their large pain relieving patches for effective transdermal drug delivery into the bloodstream. But why are pain patches necessary, and what makes them different from other forms of drug delivery methods like pills or injections? Pain patches are able to bypass the digestion tract and require no additional requirements before usage. For example, I have an iron deficiency, so I need to take iron supplements through pills. And as you can see on the back, near the suggested use part, it tells me to take 1 tablet daily with water and a meal. Meaning, to take this drug properly, I not only have to consume the medicine, but with water specifically, and with a meal. Otherwise, I could get digestion issues or even acid reflux. Pills are also usually harder for children or older patients to consume and can easily be vomited out, causing the medicine to exit the body. Shots or injections directly administer the medicine into the bloodstream, but come with their own issues. Needles cause a lot of pain and discomfort, especially to children and those who may be afraid of sharps. Shots and injections are also very expensive and inconvenient. Shots often require nurses or trained professionals to administer and can be very expensive with automated options. Pain patches resolve the issues from other drug delivery methods by administering the drugs directly into the bloodstream by also being non-invasive. Transdermal drug patches are cheap, convenient, and easy to use, while also being friendly for people of all ages.
Hi, my name is Abhishek Gupta, and I would be going over the mathematical models that were involved with the project. Some of the variables that were needed to be solved for equations had to be researched. According to recent research, the porosity of the skin was found to be 68.3. The thickness of each of the cell membranes also had to be researched to reach a further analysis of the patches. The stratum corneum is approximately 15 to 20 micrometers. The viable epidermis is approximately 130 to 180 micrometers. The dermis section is around 2000 micrometers. And the surface area of the patch was calculated to be 140 centimeters squared. For the project, we chose two of the active ingredients that we will be calculating the transport concepts for. The chosen compounds were L-menthol and menthol salicyate. L-menthol has a molecular weight of 152.15 grams per mole, and menthol salicylate has a molecular weight of 156.27 grams per mole. The drug concentration of each of the drugs was also found. L-menthol there was a concentration of 210 milligrams of L-menthol and 63 milligrams of menthol salicylate. Some other variables were also calculated for the project. Here we solve for the solute radius for each of the compounds. The figure shows the calculations that were done to find the solute radius for L-menthol and menthol salicylate. In order for us to find the solute radius, the molecular weight and the density are the two variables that were needed to be found for each of the drugs. The molecular weight was calculated to be 152.15 grams per mole, and the density was found to be 0.89 for grams per centimeters cubed for menthol. The molecular weight for menthol salicylate was calculated to be 156.27 grams per mole, and the density for menthol salicylate was found to be 1.17 grams per centimeter cubed. Using the equations, we can solve for each of the radiuses. The radius for menthol was found to be 4.078 times 10 to the negative 4th micrometer, and the radius for each of the menthol salicylate compounds was found to be 3.722 times 10 to the negative 4th micrometers. Here, we solve for the diffusivity of the drug within the tissues. In order to find the diffusivity of the cell within tissues, we would need to find the porosity and multiply by the diffusivity of the drug in water. As shown here, the porosity of the drug was 0.683 as mentioned in the beginning of the slide. That would be multiplied by 2, and then 3 would be subtracted from 0.0683, and the results would be then multiplied by each of the drugs' diffusivity within water. Using the calculations, we were able to calculate the diffusivity of methyl salicylate within tissues and the diffusivity of menthol within tissues. The membrane permeability here was calculated. In order for us to solve for membrane permeability, the diffusivity of the drug within tissue was divided by the membrane thickness. In order to get better and more accurate results, the membranes were divided into two. The first membrane would be the stratum plus the viable membrane, which came out to 200 micrometers. Here in the second figure, as you can see, the membrane permeability for the first one was calculated to be 2.921 times 10 to the negative fourth. This is for stratum corneum plus viable. As you can see, the 200 micrometers was then calculated to centimeters in order for the units to cancel out and give us the remaining units. And here, the second, we can see the membrane permeability of the drug within the dermis membrane was calculated to be 2.921 times 10 to the negative 5 centimeters per second. The following results are for menthol. Here, as you can see, the membrane permeability for methyl salicylate was also calculated. The membrane permeability for methyl salicylate was calculated to be 2.957 times 10 to the negative 4th centimeters per second for the stratum plus viable membrane. For dermis, the membrane permeability was calculated to be 2.957 times 10 to the negative 5th centimeters per second. Here we solve for the partition coefficient. In order to solve for the partition coefficient, the radius of the pore size and the solute radius was determined. Using the known values for both of the variables, the partition coefficient for each of the drugs was calculated. For methyl salicylate, the partition coefficient was calculated to be 0.99. Additionally, the partition coefficient for menthol was calculated to be 0.999 as well. Although the known values of each of the drug is different, the value came out to be very similar. Here we were able to finally solve for the mass flow rate. The first figure shows the equation that was used to solve for the mass flow rate for menthol under the stratum plus viable epidermis. The second figure shows the equation that was used to solve for the mass flow rate of methyl salicylate for stratum plus viable epidermis. The third figure here can demonstrate the equation that was used to solve for the mass flow rate for L-menthol for the dermis membrane. And figure 4 can show the equation that was used to solve for the mass flow rate at the dermis section. It is perceivable that the mass flow rate is higher when it is done in the bigger pores that have bigger size.
Hi, my name is Delvis Wenget. Being a transdermal drug delivery, salon patches must diffuse through various layers of skin. But since the patch, along with these layers and blood vessels, contain a membrane layer, understanding transport through a heterogeneous fluid or media is incredibly important. In order to understand transport through a heterogeneous medium, like membranes, the property of the drug has a great influence on the permeability through the skin. Some transport concepts that help in identifying factors that play a role in this type of transport can include membrane permeability, surface area, concentration gradient, drug radius, etc. For example, molecular size and permeation rate are inversely proportional because larger molecules would diffuse slower and less efficiently. In addition, factors like skin thickness are also important in the permeation rate through the skin. In fact, various studies have shown that the permeability of certain drugs can be different depending on the location on the skin, as the thickness of skin can change based on the part of the body you are analyzing. Device analysis. First pass effects. One of the biggest transport issues that various other methods of drug delivery face is first pass metabolism, which is the breakdown of drug through the liver and gastrointestinal system. One form of drug delivery where this has to be taken into account is through oral administration. During oral delivery, the drug moves from the mouth through the GI tract and liver before reaching the systemic circulation. When in the systemic circulation system, the drug can be transported to the desired location or target cells. Throughout this delivery, the drug may face metabolic processes such as the acids and enzymes in the stomach, intestines, and liver. However, since salon pass patches are transdermal, the drug does not have to travel through the gastrointestinal system or liver. Therefore, fear of the decrease of the dosage, which thus prevents the intended effectiveness to be fully reached, is not an issue for this method of drug delivery. Device analysis. Steady state diffusion. In addition, aside from the avoidance of first pass metabolism, another transport issue solved by the salon pass patch includes its ability to provide steady state drug concentration in the blood. This is important because under steady state condition, the drug is able to optimally impact in its intended way. Reaching steady state concentration is primarily the main goal of many therapeutic treatments, since below this intended concentration, the drug may fail to provide any benefits, while when it's above this intended concentration, the, the, the drug can lead to toxicity in the body.
Hi, this is Miss Ghana. So this feature improvement. So the current patch is working only for temporary relief of the minor pains. So our idea is to improve the patch by changing some of the compound that cause the current issue. So the ingredient of the salon pass are methyl salicylate and the elemental. So methyl salicylate is cause some issue like wheezing, tightness in the chest or throat, and difficult breathing, swallowing or talking, and swelling of the mouth, face, lips, and tongues. So all these issues are caused by the methyl salicylate. So by finding something equivalent compounds, slow pass, can be improved. Also, as researchers indicate that 47% of the patients are reported negative effects. So, by changing the new compound can be allows the active ingredients in the patch to easily penetrate through the cell membrane and less side effects. Okay, so to summarize our research, salon patch are used to relieve the minor pains. So salon pass allows the body to absorb the drug through the skin. Also, in this project, we solve some transport questions like the diffusivity of the drugs through the tissue and the membrane. Also, salon patch can be improved by solving the current issue.
For over 20 minutes.
And this is our works cited for all of our research.
How old would they be?
Thank you. This will conclude our presentation.